Welcome to Science and Reasoning. This is episode 1 titled Greenhouse Effect Modeling Dogma. Is it correct? We're going to go through the greenhouse effect and evaluate whether the claims are actually correct. So, what is the greenhouse effect? Well, according to the IPCC, some gases, let me get my thing here, some gases in our atmosphere, such as carbon dioxide, methane, and nitrous oxide, act like an insulation blanket for the Earth. They warm the Earth by making it harder for heat to be released into outer space. This effect is called the greenhouse effect, and these heat trapping gases are called greenhouse gases. Okay, so effectively what's happening is the Earth is emitting heat, and that heat is trapped by an atmosphere, and so that heat is absorbed and then re-emitted back towards the surface, and then the surface heats up. Okay, that's the general idea of it. So let's look. This is the document that I got that definition from, and they claim that the Earth is heated by 33 degrees Celsius by um, these molecules: carbon dioxide, methane, nitrous oxide, and other greenhouse gases. Similarly, Wikipedia and Encyclopedia, let's see, this is Encyclopedia Britannica, claims that the without the heating caused by the greenhouse effect, Earth's average surface temperature would be only about negative 18 degrees Celsius. Okay, so we take this negative 18 degrees Celsius, you add 33 degrees Celsius, and you get the average surface temperature of the Earth of 15 degrees Celsius. Now, 15 degrees Celsius, for those who know Fahrenheit, that's 59 degrees Fahrenheit. Wikipedia actually does a better job here. Uh, there's a negative 18 degrees Celsius without the greenhouse effect, and the let's see, less than the 20th century average of about 14 degrees Celsius. So the difference here is 32 degrees, but it's close to 33 degrees that's claimed in the IPCC. How do they get to that? Let's see. This is the black body radiator model, and I'm gonna have math here for some math nerds. Um, how do they get that? Black body radiator model, what they do is they define a system boundary, and they evaluate sunlight coming in. That sunlight hits the Earth, and it's over the cross section of the Earth, so pi r squared, and the Earth, assuming the Earth is a sphere, and then you subtract out what's reflected, which is de- depends on the albedo, which is 30%. That's a measured quantity from NASA. And that's equated to the heat emission by the Earth, which is emitted over the surface area, so 4 pi r squared. And that is shown here using the Stefan-Boltzmann equation. And then you solve for the emission temperature of the Earth, which is negative 18 degrees Celsius. So this is the model. This is how you get the negative 18 degrees Celsius. For those who use Fahrenheit, it's 0 degrees Fahrenheit. And the actual calculation uses this thing called Kelvin. It's a Kelvin scale, which is based off of absolute zero. Note that the albedo of the Earth, the reflectivity of the Earth here, is 30%. And that's a measured quantity, and that's for this analysis. So the greenhouse effect is taking that model temperature, comparing it to the measured temperature, and then the difference is that 33 degrees Celsius that we read on the Intergovernmental Panel on Climate Change from the United Nations website. So why is it important? Well, the greenhouse effect claim affects many other claims: global warming claims, climate forcing claims, regulations and bills, carbon dioxide claims, carbon footprint claims. It's the basis for carbon taxes, the Green New Deal, if you've ever heard of that, with the government. So there, it's far-reaching, this claim, because it's the basis of many other claims. The only problem is the greenhouse effect model is wrong. So why is it wrong? All right, so we have our black body radiator model, which includes the surface, atmosphere, and clouds. So that negative 18 degrees Celsius and that reflectivity of 30% are a combination of the surface, the atmosphere, and the clouds. So if you look at the temperatures for the surface, the temperature for the atmosphere, temperature for the clouds, the combination of those three ends up being negative 18 degrees Celsius. Given the clouds are negative 33 degrees Celsius, surface is 15 degrees Celsius, and the atmosphere is negative 8 degrees Celsius, you can see the emission temperature is roughly an average of those three temperatures. That's characterized here. You can see a heat emission map. So we have longitude and then on the x-axis and latitude up and down here. And you can sort of see the outline of South America here, outline of Africa here, here's Australia. And something to note is that the clouds here are blue. Now, blue is a a colder emission, and the value, this is watts per meter squared. When you back calculate out what the temperature is, it's about negative 33 degrees Celsius. And the yellow here, the 350 watts per meter squared, that is approximately 0 degrees Celsius. That's freezing, so 32 degrees Fahrenheit. And so then we're looking at this. Okay, so the heat emission, uh, the coldest emission is from the clouds. So if we were to remove the clouds, then you get rid of a lot of the cold emission, and you redefine your system as a surface, which is what they do. They claim the surface would be negative 18 degrees Celsius. Well, that is a bad assumption because you've gotten rid of the clouds in the atmosphere, and you're not taking into account that you got rid of the clouds in the atmosphere. And why is that? Well, let's look at the reflectivity. So you have reflectivity here. The clouds are the main reflectors. So the temperature, the emission temperature of the Earth, is a combination of the surface temperature, the atmospheric temperature, and the cloud emission temperature. And so is the reflectivity. That albedo of 30% is a combination of the surface reflection, the cloud reflection, and the atmospheric reflection. And given this data from satellite data from NASA near Earth observations, the main reflector is clouds. And so when we remove the clouds in the atmosphere, you then have to change the reflectivity from 30% down to 10% in your blackbody radiator model. And so we do that here. Let's do that analysis here. So modeled system is defined as the surface, and then we change our reflectivity from 30% to 10%, do the calculation, and we end up with negative 2 degrees Celsius as the surface temperature. So that's our starting point. The claim is the starting point is negative 18 degrees Celsius. That claim is from the IPCC, Encyclopedia Britannica, Wikipedia, university textbooks. It's everywhere. And so if we were to take all those different claims and put them on a graph, you see negative 18 degrees Celsius. That's that calculated, poorly calculated temperature for the surface, and 15 degrees Celsius, which is the measured surface temperature. Some claims state that it's just carbon dioxide, such as Chang from chemistry. Calculations showed that if the atmosphere did not contain carbon dioxide, Earth would be 30 degrees Celsius cooler. This is false. Absolutely false. Um, and I just proved it by doing that calculation because the actual starting point is negative 2 degrees Celsius. You have water vapor, that's a greenhouse gas. You have methane. You have all these different parts. You have clouds, and so claiming that the the majority of this jump here, this fictitious jump, is due to carbon dioxide is absolutely false. Many places they'll claim something like this, where the 33 degrees Celsius jump, which is false, is due to mainly water vapor with a large portion from carbon dioxide and then a smaller portion from trace gases. Such as the IPCC, they claim the 33 degrees Celsius increase due to greenhouse gases. But this is also false, as I just analyzed. So, what's more correct? I wouldn't say it's perfect, but it's a more correct model would be to start at negative 2 degrees Celsius. And if you're adding water vapor to the atmosphere, you have to add clouds because the water vapor evaporates from the ground, it absorbs heat emitted from the ground, and then it condenses into clouds that then absorb heat emitted from the ground and emit heat back towards the ground. So there's many different effects from the water vapor in the atmosphere evaporating and condensing. So we have to include clouds and water vapor as kind of one bar, which is why it has a different color. All right, so how do we determine the actual effect from heat trapping gases? We have to look at something like a simple cloud model. So we'll take our original -2 degrees Celsius of the Earth and redefine our system now to include clouds. So you have the clouds above the surface, and we draw our system boundary again um, around our system, the clouds and the Earth's surface. And we take I'm going to do math again here. The sunlight coming in minus the reflected sunlight, and that equals heat emission. Well, this is heat emission from the clouds plus heat emission from the surface. I know there's a lot of factors in there. You have things such as F, that's the cloud fraction. You have the emissivity of the clouds. You have the temperature of the clouds. Again, you have the surface area of the Earth. This sigma is Stefan Boltzmann constant. And then you have 1 minus F, which is the fraction of the Earth where the clouds aren't covering, the emissivity of the surface, and then the temperature of the surface. Now, the cloud fraction is a known quantity. From NASA near Earth observations, you can get cloud fraction data for every month going back years. And when you plot that, it's about 65 to 70%. So I just assume 65 here. And then the reflectivity in this analysis, I'm just assuming it's the albedo of 30%, because as I showed before, clouds are the main reflector. Clouds are now part of the system, so this makes sense having it as 30% reflectivity or albedo of 30%. When we remove clouds, it was just the reflectivity of the surface, which was 10%. So adding the clouds back in, that's why the assumption of 30% reflectivity makes sense. Now you have two unknowns in this equation. You have the cloud temperature and you have the surface temperature. The emissivities are just assumed that of water because cloud droplets are water and the surface is mainly water. So the emissivity is just assumed to be 0.96, which is from standard heat transfer textbooks. But I digress. You have the surface temperature, you have the cloud temperature, you have one equation, so we need a second equation equating the two. And we all know that clouds are up in the atmosphere above the Earth's surface, and there's a temperature difference between the surface and the top of the clouds. And the top of the clouds is what we're looking at because that's what's emitting out into space. It's emitting across the system boundary. And the top of the clouds on average is about 7 kilometers. I got that in my book from a paper. So it's about 7 kilometers to get up to the average height, top height of the clouds. And the lapse rate in the atmosphere, which is the change in temperature in the atmosphere, is about 6 degrees Celsius per kilometer times 7 kilometers. That's about 40 degrees Celsius difference between the surface temperature and the cloud temperature. And when you do the calculation, you end up with 8 degrees Celsius and negative 32 degrees Celsius for the clouds. And so what that tells us is adding clouds causes a greenhouse effect. And because we went from -2 to 8 degrees Celsius on this surface temperature. And so when we go back here, we can assume that this portion of the greenhouse effect is just by adding clouds, and we can assume that the remainder is from heat trapping gases in the atmosphere. Now, if you look at the remainder, the majority is from water vapor, and then a small portion is from carbon dioxide, and an even smaller portion is from trace gases. So, what is the summary here? The standard greenhouse effect claim, which is considered dogma, it's universally accepted as true, is demonstrably false. I'm surprised that no one has called them out on it or even sued them over it, but every single source says the same thing, which in this analysis I showed you, it is demonstrably false. And it's pretty sad because it's the main claim for many claims in the climate narrative. And so the reality is the greenhouse gas effects are about 5 times less than claimed. And carbon dioxide's greenhouse effects are only about 2 degrees Celsius. That's the heat trapping effect of carbon dioxide. Some sources say it's 30 degrees Celsius. That's wrong. Others are, assume roughly 1/3 of the 33, so around 10 degrees Celsius, but both of those are wrong. It's only 2 degrees Celsius. So this affects many climate claims, and the determinations from those climate claims, such as carbon taxes, such as the Green New Deal, they are now in question. So I thank you for listening to me. Thanks for watching. Please support me by buying my book on Amazon. The title of the book is How to Model Climate, the Mathematical Approach. You can also contact me at the email shown here. Thank you very much. Bye bye.